Hello and welcome back to chemistry practice. Today we're going to delve into the realm of stoichiometry. It seems like a big word and it seems complicated at first, but if you follow some simple steps, it's not that bad. So, the first thing we're going to look at is something called mass to mass. I could go into a big long explanation, but the best way to learn this is just by doing some practice problems. So here we have the very first practice problem we're going to do. It's a common sort of problem that you will find in books or on worksheets. Let's go ahead and read it. How many grams of chlorine can be liberated from the decomposition of 64 grams of gold chloride? Now, when you first read this, your brain tends to shut off because you say, what did I just read? But let's just look at this a little bit closer. They give us 64 grams of gold chloride. This is gold chloride. So we know we have 64 grams of this stuff. It's going to decompose, which means it breaks apart into gold and chlorine. I can just read that by the equation. So now if I have 64 grams of this stuff, how much chlorine will I get? That's all this is saying. So, to do this problem, we have to remember some simple steps. First, always start with a balanced equation. This equation is not balanced, so we're going to have to balance it. And we have one gold here, but one here, but we have two chlorines and three chlorines, so let's just go ahead and put 2 gold chloride. Now I have 2 gold, so I'm going to need at least 2 gold over here. That seems to work. Plus, I have 6 chlorines here, so let's put 6 there. This is now balanced. Okay. After I balance it, I need to take my grams of the substance that I'm given and convert it to moles. We always need to work with moles because that's going to be easier for us. So, this is called a mass-to-mass stoichiometry problem because we're given a mass, 64 grams, and they want us to find the mass of something else. So to do this problem, we're going to go from mass to moles back to mass. And I'm going to show you how to do that. So let's get our 64 grams, and I'll put it over here, 64.0 grams of gold chloride. And I'm going to convert this to moles. How many moles of gold chloride do I have? Well, I will use a conversion factor. I know 1 mole of gold chloride equals 303.32 grams. You're probably saying, wait a minute, hold up, where did this number come from? This is a molar mass. Really all I'm doing is going to the periodic table. I'm looking at gold. Let's go to the periodic table and look at gold. And gold is 196.967 grams per mole. So 196.967, that's gold. Now I have chlorine. Go to find chlorine, 35.453 grams per mole. So this is times 3. I have 3 chlorines. I have 1 gold. I multiply this number by 3. I add the gold. That's where this number comes from. This is the molar mass of gold chloride. Okay. So at this point, I've gone from grams of gold chloride to moles. Now this next step is where people get confused. I have to look at a ratio from what I want to go from to what I want to go to. So I want to go from gold chloride to chlorine. So I need to look at the mole ratio of this substance to this substance. Now down here, I've balanced it. This coefficient here is how many moles of this substance will produce how many moles of this substance. So theoretically, if I had 2 moles of gold chloride, it's going to produce 3 moles of chlorine. That is a ratio. The ratio is 2 to 3. So I need to write that down right here. So 2 moles of gold chloride equal 3 moles of chlorine. That's why you need to balance this equation properly, because those coefficients matter. Make sure you put the 2 here, because this is chlorine gas. So you're probably saying, why did you put gold chloride in the bottom? How do I know what to put in the bottom and what do I put in the top? And the answer is very simple. I look over here. Notice I have gold chloride on the top. Well, when I go to cancel them out, I need gold chloride on the bottom. This is dimensional analysis, which we did in the very first unit of chemistry. Now it matters. You're going to be doing a lot of dimensional analysis, so make sure you have the units written out. Now I need to go from moles to mass. So let's look at this. I went from mass of gold chloride to moles of gold chloride. Now I went to moles of chlorine. That's what this step is. And now I need to convert chlorine back to the mass. So I just do the opposite of what I did here. I know that 1 mole of chlorine equals 70.9 grams of chlorine. And when I do the math is 64 divided by 303, just ignore these ones, 0.32, times 3 divided by 2, times 70.9 equals 22.4396. And I could go back and look at significant figures. They gave me 3 significant figures, 6, 4, 0. These are all significant. So I could round this to 22.4 grams of chlorine. And that is my answer. So if I am given 64 grams of gold chloride, I will produce 22.4 grams of chlorine gas. Let's look at some common mistakes. The first common mistake is I notice in class people don't balance it. Okay, the second common mistake I notice is people write down these molar masses wrong. They calculate them wrong. You're probably thinking, wait a minute. All you have to do is go to the periodic table, look up some numbers, do some simple multiplication, and add them. Trust me, I myself have miscalculated. I look at the wrong substance. I'm going too fast, not paying attention, and I get the wrong number here. It happens all the time. I also notice in class, kids are trying to hurry. They just want to get the assignment done. I can't stress this enough. Speed is your enemy in chemistry. You don't want to hurry through these problems, because the moment you hurry through them is the moment you make a very simple mistake and you will get it wrong. And I also notice students in class are talking as they're doing this. Yet again, you get unfocused, you make little mistakes. And lastly, I notice that students in class don't have neat work. Neatness is your friend in chemistry. The neater this is, the neater you write this out, the better off you're going to be. So let's look at the simple conversion factors here in the dimensional analysis. Grams of gold, cancel with grams of gold. Moles of gold chloride, moles of gold chloride, moles of chlorine, moles of chlorine. I'm left with grams of chlorine. Now, I always advise students to write out the units. Notice how I forgot the unit here, which would be gold chloride, because then I know what I'm canceling out. That helps you understand the process. Okay, so that is a very simple mass-to-mass stoichiometry problem. Let's go down to the second question. Calculate the mass of silver chloride that can be prepared from 200 grams of aluminum chloride and sufficient silver nitrate. Okay, so calculate the mass of silver chloride. First of all, I have to identify what this stuff is. This is silver chloride right here. that can be prepared from 200 grams of aluminum chloride. This is aluminum chloride. So essentially in this question, by the way, this is already balanced. I have 3 NO3s over here. I have 3 NO3s over here, 1 aluminum, 3 chlorine. So this is balanced. In this question, essentially, this and this don't matter to me at all. And we're starting to notice one other thing. I have to make sure I understand how to read formulas and read a formula and convert it into the actual formula. So now that whole unit on ionic bonding is starting to become very important. So if you didn't pay attention in that unit, you need to go back and look at that unit again. So yet again, I have 200 grams. I start over in the top left. 200 grams of aluminum chloride. I want to go from this to moles. I know 1 mole of aluminum chloride is 133.341 grams of aluminum chloride. Okay, now I want to get a ratio between these two substances. I know if I have 1 mole of aluminum chloride, notice how there's no number here, so that should be a 1. 1 mole of aluminum chloride. I should get 3 moles of silver chloride. Okay, at the end of this step, I should have moles of silver chloride if I did all this math. But now I want to go to grams of silver chloride. So I know 1 mole of silver chloride equals 143.32 grams of silver chloride. And yet again, to get this molar mass, I just go to the periodic table, find the molar mass of silver and chloride, and add them. Now I do all this math, so 200 divided by 133.341 times 3 times 143.32, and I should get 644.902 grams of silver chloride. And I was given 3 significant figures. Notice how there is a decimal there, so those 2 zeros count. So I could round it off to 645 grams, because that's significant, that's significant, that's significant. Now this number is going to have to be rounded, and that's a 9, so it's 645. So that's my answer, 645 grams of silver chloride. Yet again, I could look at how it cancels. Grams of aluminum chloride, grams of aluminum chloride, mole of aluminum chloride, mole of aluminum chloride, mole of silver chloride, a mole of silver chloride, and now I have my answer, grams of silver chloride. I have noticed in class that a lot of students don't want to write down the units. It seems like a lot of work. And I advise that you write down the units until you are very comfortable with what you're doing. Honestly, I advise that you always write down the units, because if you make a mistake, you can go back here and make sure that you actually found the right molar mass of the right substance. Because people make mistakes. Sometimes people, by accident, put down the aluminum nitrate right here. So always put down the units. Okay, I hope you're gaining a little bit of confidence. When you start to get good at this, it feels pretty good. And I know I always say this, but it's sort of like a Bob Ross moment. It's very Zen-like. You can just go through these and do them over and over. Calculate the mass of lead iodide produced. First of all, what's lead iodide? That's this thing here. Honestly, for some reason in my mind, I often get lead and iron mixed up. I have no idea why my brain does that, but I've done it a lot. So we have lead iodide produced by reacting 30.0 grams of potassium iodide with excess lead nitrate. What does that mean? It means we have a bunch of this stuff here. We have enough of this stuff, however much we need, to react with 30 grams. Now, one of the things you're going to be doing next is limiting and excess reactants. But we don't need to worry about that right now. So let's just look at this. If I have 2 moles of potassium iodide and I add it to lead nitrate, it's going to react, and I'm going to get 1 mole of lead iodide and 2 moles of potassium nitrate. So yet again, they're giving me 30 grams. Start with 30.0 grams of potassium iodide. Yet again, they give me mass and I need to go to mass. So this is a mass-to-mass stoichiometry problem. First thing is convert to moles. 1 mole of potassium iodide. Go to the periodic table, look this up, which I've already done, as you can tell, because trust me, I don't have this memorized. I wish I did. 165.998 grams of potassium iodide. Okay. Now I need to look at my conversion factor from this to this. Not conversion factor, but ratio, sorry. Well, if I have 2 moles of this, I get 1 mole of this. So 2 moles of potassium iodide will equal 1 mole of, sorry, and this is where I'm not following my own rule, which is to be neat. 1 mole of lead iodide. Now I need to transform lead iodide into grams. So I'm going from mass to moles, back to mass. 1 mole of lead iodide equals 461 grams of lead iodide. So do the math. 30 divided by 165 divided by 2 times 461, and I'm going to end up with 41.657 grams of lead iodide. Yet again, I have 3 significant figures, so just round this to 41.7 grams, I guess. And let's see if our units cancel out. Grams, moles of potassium iodide, moles of potassium iodide, moles of lead iodide, moles of lead iodide. I ended up with grams. And that's what I wanted, the mass of lead iodide. And that's what I got. Okay, well, that's enough for now. Next lesson, I'm going to go into a little bit more detail. Maybe I'll do percent yield, or maybe excess or limiting reactants. We'll see, or maybe I'll start adding in a little bit of volume stoichiometry. We'll see. But I hope that helped you out. Remember the basic steps. Let's just go over them again one more time. First, balance the equation. Second, write whatever you're given up in the left-hand corner and then convert it to moles. Then write a ratio between what you are given and what you want. So what am I given and what do I want? What is the ratio between these? What is the mole ratio? Then find the grams of what you want, because now I have moles of what I want. So 4 simple steps, 4 simple boxes here. Okay, I hope that helped. If you have any questions, let me know. Thank you.